Hey everyone, welcome to this channel. Today we will be diving into the world of non-parametric statistics and exploring the Wilcox Signed Rank Test. This powerful test helps us compare two related samples and assess if their median difference significantly. We will be implementing it in Python. So, how to perform the Wilcox Signed Rank Test in Python using SciPy and Penguins library. This is our today's video. Wilcox Signed Rank Test is a non-parametric alternative to a pair t-test. It doesn't assume normality in the data distribution and focuses on the rank of the difference between two paired and dependent samples. So let's have a look in the data. We have a data set. In this data set, we measure the blood pressure before and after the treatment of a group of individuals. Our data look like this. Here we have a subject, and subjects have twice readings before and after. The values indicate that the blood pressure is taken before and after the medication. So first we import here our libraries like an import pandas as PD, and we also import from SciPy, import stats, and we also import from scipy.stats import Wilcoxon test, and we run this code of the chunk. Now we have to read our data. For reading a data, we write here data underscore pressure. This is our vector, and we say to read this data using a pandas function pd.read underscore excel, and open the bracket, double quotes, and we just give the name of the file. We test this, and data on this file exists on a sheet name equals to 1, and we just run the code here. Without error, we got reach here, and we can see our data, how it looks like, data underscore pressure. And we can see here we got our subjects, blood pressure before the medication and blood pressure after the medication. And we have here the total number of readings are 25. So in method for Wilcoxon test using Penguins library. So to perform the Wilcox test using a Penguins library, we need our data in a longer format. This is the first requirement of the Penguins library. So first we use our pandas function, and we here says like a blood pressure BP1 equals 2. Because we are going to put this longer data or pivot longer data in this vector. So we write here pd.mal function, and we open the parenthesis, and we write here data underscore pressure is in our data set which we are using in this method. And here we just say id underscore variables equals to is our subject. Id underscore variables is our subject, and we put in a comma sign here, and we write value underscore variable, and that's we also goes in the square bracket, and we write before and after in the double quotes, for and comma, and again double quotes, and we write here comma, and we say the variable underscore names, and names will go in the column called time, and here we just write a value underscore names that will be in a pressure, and we just run this code of the chunk here, and it's again giving us problem. I make a mistake again here. I need capital S, and we just run the code of the chunk, and we see we have no problem to run the code, and we just come here, we write an BP1 just to see our longer format of the data, and we can see we got the subject, and as a treatment we got time points before and after, and the values we converted into pressure. So this was the first requirement for perform test in the Penguins library that we successfully achieved here. And now to perform the test in Penguins library, we also perform the Penguins test same to check normality of the data in the Penguins using a Penguins library. We say import penguin as pg because we need this library here, and we run the code, take a few seconds, and we are ready. So now we write here, because Penguins library we imported as pg, we write a pg.reality, and we open the bracket, and we say our data frame was a bp1 comma dv equals to dv is called the dependent variable in the Penguins library, and we can say here dv equals to we want our dependent variable is in the pressure. we put a comma after it, and group. What is a group here? Group is our treatment. Group equals to, we just write here treatment, and our treatment is in a before and after stay in the time column. So we just write here time, and we just run simply the code, and we can see here Penguin's library giving a very nice output, and it's showing us the time points before and after the reading. W value of normality test, it was a 0.97 and 0.91, and the p value is also showing here, and the normality test, either it passed the normality test or not. So as the answer is true and false is the same what we perform in using the SciPy. Using the Penguin's library is very nice because it gives a result in a one single line of code. We insert the one more code of chunk here, and we perform the Wilcoxon Signed Rank Test here using the Penguin's library, and we just simply write here pg.wilcoxon, and here we just say our data. And yes, remember, to do a Wilcoxon test need the same as SciPy, the two data frames, and for this we are using our first data frame of blood underscore pressure. So we are going to use our original data frame data underscore pressure to perform the Wilcox test in a Penguin's library. So here we'll just write data underscore pressure, and we just give the same as in a double quote after, and we just comes here, put a comma sign, and we again say data underscore pressure. We open the bracket and put here, and we just write here before. So we already give it here to Penguins our readings before and after the measurement of the blood pressure or medication. Now we just write here alternative, we put a comma, alternative equals to two-sided because it's a pair sample, two-sided, and we also give the method equals to, we say exact, comma, and action equals to, we say false, and we simply run the this code of chunk here, and you can see providing a very nice output in a one line of code with the information as if the test is performed as a Wilcoxon test, and Wilcoxon test value is an 18. We use alternative as a two-sided. P value is also a 0.0015, that is called 1.5 into 10 to the power minus 4. This is highly significant. Here the important thing is it's telling about rank by serial, and it's providing us a minus sign in this, so it's saying the distance between the medians of the two samples are very less. But how much less? Is really effective or not, that we can compute the size effect of this samples. And to measure the size effect, we use again the penguin.put function, put size effect, and we just open the parenthesis here, and here we need to give the data frame same as earlier, pressure, open the bracket after, and data underscore pressure, open the parenthesis, and give the before. And here to check, because our samples are paired, so we have to give the condition of paired equals to true, and we put a comma sign, and the important function called effect type. In the effect type we have to give test that you can see here in this library have a none for no size effect. If we want to check a size effect, we coherence, unbiased coherence, H also we can use. If we want to check the Pearson correlation coefficient, we can use here R, and CLS was a common language size effect. So here we are choosing a coherence, we use a double quotes, and we just write coherence, and we run the code, and it's giving us output as a minus 1.5. That indicate that we have very less size effect on the sample. So that's all for this video. Stay tuned for the more insightful tutorials on statistical analysis and data visualization. Don't forget to like, share, and subscribe for more content on the data analysis and the programming tutorial in Python. Thank you for your attention.